Hello everyone. Now in that sessions we are to study about battery. So what is battery? So battery is a device which stores the energy in the form of chemical energy and gives electrical output. That means it is a device that converts a chemical energy into electrical energy. Now batteries have high energy density but low power density. And for getting a high energy, number of cells are connected to form a battery pack. Now example of battery are lead acid battery, then lithium ion battery or Li-ion battery. Now the rating of battery is measured in ampere hour. So what is ampere hour? So ampere hour it measures a charge passing at a steady state current in a 1 hour. Now capacity of battery it is the amount of charge per unit weight or volume for material unit of ampere hour per kilogram or milliampere hour per gram. So that is a capacity. Now cathode capacity. So what is cathode capacity? How much Li can it provide to move a pack and forth? So that is cathode capacity. Then anode capacity. How much Li can it hold or accommodate from the cathode? So that is anode capacity. Then next is C rate. So what is C rate? So full charge or discharge of cell in a particular amount of time, and 1C is equal to 1 hour. So 10C is equal to 1 by 10 hour and C by 10 is equal to 10 hour. C rate is used to describe how fast battery charge and discharge. For example, a 1C battery need a 1 hour at 100 ampere to hold 100 ampere hour. A 2C battery would need just a half hour and hour to load 100 ampere hour, while 0.5C battery requires 2 hours. So that is a C rate of battery. Now here a construction of the battery is shown here. So here a rated capacity is shown, then available capacity, then SOC that is state of charge, then the stages of battery that is empty stage, then stored energy, then inactive are shown in that figure. Now note that battery anode is always negative and cathode is always positive. That means anode terminal is always negative and cathode terminal is always positive. Now next is types of battery. Now there are the two basic types of battery that are non-rechargeable or primary, and second one is secondary. So what is non-rechargeable or primary? So this is a type of cell can be used to get a energy for one time. This cells works on spontaneous forward reaction. The product from can't be converted to reactant by applying electric field. For example, dry cell or alkaline cell that are the example of primary or non-rechargeable battery. Now second one is secondary type. Now this type of battery can be used again and again by charging it. This cell operate near a equilibrium and reaction are reversible. For example, lead acid battery or lithium ion battery that are the example of secondary type. Now next is most commonly used battery. For portable device, dry cells are used. Then lead acid batteries are used in vehicles, and lithium ion batteries are used for portable electronics such as laptops and smartphones. Now specification of lead acid battery that are specific energy required is up to 33 to 42 watt hour per kilogram. Then specific power is 180 watt per kilogram. Then charge or discharge efficiency is up to 50 to 95%. Then self discharge rate is up to 3 to 20% per month. Then cycle durability is greater than 350 cycles. Then nominal cell voltage up to 2.1 volt. Then specification of lithium ion battery, that are specific energy 100 to 265 watt hour per kilogram. Then specific power 250 or 340 watt per kilogram. Then charge or discharge efficiency is up to 80 to 90%. Then cycle durability 400 to 1200 cycles. Then nominal cell voltage, NMC 3.6 by 3.85 volt, LIFE pure 43.2 volt. So that is nominal cell voltage. Then what is battery banking? For large amount of energy storage, we need a number of batteries, and for this purpose, batteries are connected in series and parallel. By series connection, voltage of battery bank is increased and parallel current is increased. In an battery bank, by using a battery management system, a life can be increased. So that is battery banking. Now, procurement related to batteries, that are purchase batteries from a reputable manufacturer or suppliers. Then avoid batteries shipped without protective packaging, that is hard plastic or equal. Then inspect batteries upon receipt and safely dispose of damaged batteries. Then storage regarding batteries. Store batteries away from combustible materials. Then remove batteries from a device for a long-term storage. Then store batteries at a temperature between 5 degrees centigrade to 20 degrees centigrade. Then separate fresh and depleted cells or keep a log. Then if practical, store batteries in a metal storage cabinet. Then avoid bulk storage in a non-laboratory areas such as office. Visually inspect battery storage area at least weekly. Then charge batteries in a storage approximately 50% of capacity at least once every 6 months. So that is storage related to battery. Then chargers and charging practice, that are never charge a primary battery, then store one-time use battery separately, then charge or discharge battery approximately 50% of capacity before a long-term storage, then use charger or charging methods designed for the battery, then disconnect batteries immediately if during a operation or charging they emit an unusual smell, heat, or behave abnormally. Dispose of batteries. Then charge and store batteries in a fire retardant container. Then do not parallel charge batteries of varying age and charge status. Then do not overcharge greater than 4.2 volt for most batteries or overcharge discharge below 3 volt batteries. So that is chargers and charging practice. Then handling and use. Handle a batteries cautiously. Then keep batteries from containing conductive materials, water, strong oxidizers, and strong acids. Then do not place a batteries in a direct sunlight on a hot surface or in a hot locations. Then keep a flammable materials away from the operating areas. Then allow time for cooling before charging a battery that is still warm. Then disposal. Disposal of damaged cells and cells that no longer hold sustained charge. Okay.